Hi physics students, this is Mr. Rick, and today we're going to be talking about motion and forces. What exactly is a force? A force is going to be a push or a pull acting on an object, and forces change the motion of an object. And we measure forces in a unit called newtons, and we use the capital letter N to represent newtons. And if you are curious, what exactly does 1 Newton of force actually feel like? Well, if you were to imagine resting an apple in the palm of your hand, the weight of that apple pressing down on your hand is going to be equal to about 1 Newton of force. We're first going to start off by talking about balanced forces. Balanced forces occur when the forces acting on an object are equal in size and they point in opposite directions. And when forces are balanced, there is no change in motion. So we can go ahead and look at our first example here of a person sitting in a chair. And you can imagine a person sitting in a chair, there's really no change in motion. The person's not falling through the floor or the chair or anything like that. They're kind of at rest. And anytime that there's no change in an object's motion, we know that forces are going to be balanced. So we can see here that there's actually a pair of forces acting in this scenario. There's the weight pulling down from the person, but there's actually a force exerted by the chair that is equal in size and opposite in direction towards the force exerted by the person. So we have balanced forces in this example. The weight pulling down is equal in size and opposite in direction to the force of the chair pushing back up. Our second example is going to be when forces are not balanced, and we call these unbalanced forces. Unbalanced forces acting on an object are not equal, and this results in a change in motion. And we have a scenario here where we have 5 people participating in a tug-of-war match. We have 3 people to the left and 2 people pulling towards the right. And if we were to just assume that each person can pull with equal force, well, there's more people on the left, so there's going to be a bigger pull towards the left. And this ultimately results in unbalanced forces. And so we could imagine if there is a stronger pull towards the left than to the right, the rope will actually start moving towards the left or accelerating to the left. Unbalanced forces result in a non-zero net force. And you can think of a net force as this is the combined forces acting on an object. And it results in a change of motion once again. So if we were to kind of think of these arrows or these forces being able to cancel each other out, the force on the left is slightly bigger than the force on the right. So even if the green arrow was to cancel out part of this blue arrow, there's still going to be some force left over, and we call that the net force. So we're going to go ahead and take a closer look at what net force actually is and how we can determine that. So let's go ahead and let's imagine another scenario of a tug-of-war match, but we're going to go ahead and add a little bit more information. Let's go ahead and say that each person can pull with exactly 20 newtons of force. What would the total applied force for the team on the left side be? So if we wanted to know what is the total applied force for the team on the left, we would want to consider that each person pulls with a force of 20 newtons, and there's 2 people, so that would give us a total of 40 newtons. All right, so 40 newtons of force for the left team. And what would the direction be? Well, we can see that they're pulling towards the left, so the direction of our arrow is going to be towards the left. So the left-hand team is pulling with 40 newtons of force towards the left. What would be the total applied force for the team on the right-hand side? Well, we have more people, and we have 3 people, and each person pulls with 20 newtons of force. So if we were to do that math, 20 newtons of force times 3 people would give us 60 newtons of force. All right, so 60 newtons of force for the right-hand side team. And you can see that they're pulling towards the right, so we would draw that arrow towards the right. Right? So the right-hand side is pulling towards the right. Now, you can think of it like this. What would be the net force acting on the rope? Well, you can think of it as they kind of cancel each other out. So if we have 40 newtons of force going towards the left and 60 newtons going towards the right, we would have 20 newtons of force left over moving towards, well, let me add my units, 20 newtons of force moving towards the right-hand side. So the 40 newtons of force from the right cancel out 40 newtons of force, 40 newtons of force going to the left, cancel out 40 newtons of force going to the right, and we are left with a net force of 20 newtons towards the right. So let's take a look at this scenario. So we have similar situations, and here you can see that the size of the forces for each team are given to you, and the direction of the force for each team is given to you. Now we need to consider, what is the net force acting on the rope? In our first scenario, we have 300 newtons of force going towards the left and 300 newtons of force going towards the right. And so they're going to cancel each other out with no remainder, right? So we would have a net force of 0 newtons. And because we have balanced forces, they're equal in size and opposite in direction, there is 0 net force, so we will have no change in motion. But let's take a look at the situation number 2. Here we have unbalanced forces. We have 400 newtons pulling towards the left, and we have 300 newtons pulling towards the right. These forces will cancel out, so the 300 newtons from the right will cancel out 300 of the newtons going towards the left, and we'll be left with 100 newtons of force moving to the left.